Hello students. So today we are going to discuss alternating current JEE PYQs. So this is the disclaimer. Learning objectives: after this lecture you will be able to solve numerical problems involving calculation of inductance, capacitance, impedance and RMS values in various AC circuit configurations like pure resistive circuit, pure inductive, pure capacitive, or RL, RC or LCR circuits. Okay, these are possible combination of AC circuits. Or determine quantities like power consumption, wattless current and phase differences. So let's begin with first question. So question is, the phase difference between the alternating current and EMF is pi by 2. Which of the following cannot be the constituent of the circuit? Okay, so phase difference between alternating voltage and current is given. So you have to determine which of the following given options cannot be constituent of the circuit. Okay, means what component should be there for phase difference pi by 2. Okay, so we know that if the circuit is only inductive or capacitive, purely capacitive or purely inductive, then the phase difference between current and EMF is pi by 2. Okay, for any other combination, can phase difference be pi by 2? Okay, so you have to determine the correct option. So I will give you some time to think about it. So D option is correct. RL circuit. In RL circuit, phase difference between alternating current and EMF cannot be pi by 2. Why? So for purely inductive or capacitive circuit, phase difference between current and voltage is pi by 2. I have already mentioned that if the circuit is purely inductive or capacitive, that means option B and C is incorrect. Okay, means what is asked in the question that cannot be constituent of the circuit. But purely capacitive, in case of purely capacitive and inductive circuit, the phase difference is pi by 2. Okay, so which of the options cannot constitute the circuit which is in which the alternating current and EMF is having pi by 2 phase difference? Okay, so purely inductive and capacitive circuit, phase difference between current and voltage is pi by 2. So this option B and C is incorrect. So for purely resistive circuit, if the circuit is purely resistive, then phase difference between current and voltage is given by 0 degree. Current and voltage are in phase in the case of purely resistive circuit. Okay, so when R is combined with L or C, when resistor is connected with inductor or capacitor or both inductor and capacitor, okay, the phase difference lies between 0 to pi by 2. Okay, in case of inductor, voltage leads the current. In case of capacitor, current leads the voltage. Phase difference is between 0 degree to pi by 2. It is magnitude of phase difference. Okay, phase difference can be negative. In the case of inductor, phase difference is negative because voltage leads, current lags behind the current. Okay, but if we are only taking magnitude, not considering negative sign, so phase difference is between 0 to pi by 2 if a resistor is connected to either inductor or capacitor. When the constituent of the circuit is RL or RC, whether it is RL circuit or RC circuit, phase difference lies between 0 degree to pi by 2 degree, pi by 2 radian. Okay, this means so option D, RL is correct. Okay, and why option why option LC is not correct? First option was LC circuit, because for both inductor and capacitors, for both inductive circuit and capacitive circuit, or we can say capacitor or inductor, if they are connected in series, the voltage phasor due to both capacitor and inductor are with pi by 2 phase difference with current, and they are exactly opposite to each other. So when we are taking the resultant or combination of these two phasors, two voltage phasor due to capacitor and inductor, they will, after taking resultant, the resultant will be in the direction of VC or VL, either VC VL. Okay, resultant is also having phase difference pi by 2 with the current. We have seen in the phase diagram, when we take VC plus VL, combination or resultant of these VC phasor and VL phasor, voltage across L and voltage across capacitor. Okay, so resultant of this phasor came out to be having phase difference pi by 2 with the current. Okay, so LC circuit is also not the circuit in which phase difference or between alternating current and EMF is other than pi by 2. Okay, so we have to determine which of the following cannot be constituent of the circuit. So RL circuit, in RL circuit, phase difference between current and voltage is not pi by 2. It is between 0 degree to pi by 2. So option D is correct. An arc, second question, an arc lamp requires a direct current of 10 ampere at 80 volt to function. Okay, so an arc lamp, there is an arc lamp, there is an arc lamp, it is operating on direct current 10 ampere and voltage 80 volt, DC voltage, direct current. So DC voltage 80 volt and DC current 10 ampere. If it is connected to 220 volt, if it is connected to AC supply having RMS voltage 220 volt, the series inductor needed for it to work is close to. Okay, now you can see an arc lamp requires 80 volt of DC, but RMS value of AC supply is 220 volt, which is very much greater than 80 volt. Resistance of the bulb is fixed in both the cases, when it is connected to DC, when it is connected to AC, because resistance doesn't depend on the frequency. Okay, so resistance remains same. So power, rated power, or we can say power dissipated, will change if we are connecting the same bulb with the AC supply having 220 VRMS value. Okay, so the power dissipation will change, it will get fused. Okay, so we have to flow the same amount of current through the circuit, means 10 ampere in the case of direct current, and IRMS should also be 10 ampere. Or we can say we will divide the voltage among resistor, and we have to connect a series inductor in the series, so that voltage can be divided over two components, and only 80 volt VRMS value will be along the bulb. Okay, so we have to deliver the same power in the case of AC circuit also. So the series inductor needed to be inserted to work is close to. Okay, so that bulb will glow with the same brightness and it will not fuse. So what amount of inductance we need to connect in series with the resistor, or we can say an arc lamp. Okay, so options are 0.044 Henry, 0.065 Henry, 80 Henry, or 0.08 Henry. So I will give you some time to think about it. So answer is B option, 0.065 Henry. Okay, so what is given in the question? First we have to list it. DC supply I equal to 10 ampere. DC supply voltage 80 volt. Now we have connected this arc lamp to an AC supply. So AC supply voltage VRMS is 220 volt. AC supply frequency nu is equal to 50 hertz. Okay, a lamp needs the same amount of power to work properly, whether you connect it to AC or DC. So we have to the lamp requires same amount of power, means the power delivery should be same, whether we are connecting it to AC supply, whether we are connecting it to DC supply. So power delivery should be same, power dissipation should be same. Okay, for that we know that for power resistance is same, because arc lamp is same, we are connecting it to DC then AC, so resistance will not change. But IRMS and VRMS is changing, so we have to connect an inductor in series so that current in the series will be same as DC current 10 ampere, and voltage across the resistor will be same as the DC voltage. But in case of voltage, we have to take the phase differences or phase diagram, that will make it complex. So we'll solve it with the help of in the terms of current. So power dissipated is equal to IRMS square R, or power delivered or input power for the arc lamp. Okay, so power delivered will be P equal to IRMS square R. So R is same in both cases. So we have to ensure the IRMS equal to 10 ampere. By taking that condition, we will find the inductance. Okay, so for this to happen, the RMS current in AC must equal the steady current value in the DC. So this is the definition of root mean square value. What is root mean square value of AC? So root mean square value of AC current is equivalent to DC current, which produces same power loss as AC in one complete cycle. Okay, in the time of one complete cycle, the RMS value of AC current is equivalent to that amount of DC current which produces same average power loss. Okay, so average power loss is, in the case of DC, it is I square R. In the case of AC current, it is IRMS square R. So IRMS should be equal to I for producing same average power loss. Yeah, so, or we can say for producing same average power delivery or dissipation. Okay, so we have to consider RMS value of current in the AC circuit must be equal to the steady value in DC. For example, if lamp needs 2 ampere DC, it needs 2 ampere RMS in AC. Okay, this is because RMS current is specially designed to tell us how effective current the AC supply provides. This is the effective current that AC supply provides. Okay, on this principle of power dissipation, special ammeters that are measuring AC currents, AC ammeters and AC voltmeters are working. Hot wire principle. Okay, so on the principle of energy dissipation or power dissipation. Okay, so it helps us compare AC and DC current directly. That means therefore we can switch the lamp from DC to AC. For what condition? DC current should be equal to AC current IRMS value, or we can say AC current IRMS value should be equal to DC current I. This ensures the lamp work exactly the same in both cases. If current flowing through the lamp is same in both cases, so it will be working same in both cases. Okay, the impedance of an RL circuit is given by, so what is the impedance of RL circuit? Z equal to root R square plus XL square. Okay, according to NCERT question 7.26. Firstly, we have to find the resistance. Then we have to find the XL. So from XL, we have to find the L. We have to find the L, the series inductor needed it for to work it to close to. Okay, so series inductor needed for it to work is close to. So close value we have to find. So firstly we have to find the impedance and R. So XL is equal to 2 pi nu L. So to find L we need R and Z. Okay, so we can put XL equal to 2 pi nu L, but we have to, for finding L, nu is given in the question 50 hertz. To find L, we have to find first Z and R. So calculation of R using Ohm's law. So that lamp is operating on 10 ampere current and 80 volt DC current, DC voltage. So we can find the resistance by Ohm's law, V equal to IR. So R will be equal to V upon I. So R is equal to 80 upon 10, which is equal to 8 ohm. So we have found the resistance. Now we will find the Z. So how we can found the impedance Z? IRMS is given by VRMS upon Z. VRMS is given in the question, which is 220 volt. Okay, IRMS should be equal to, we have put the condition at the very first place, that IRMS should be equal to the DC current, so that the glow in the arc lamp or arc lamp will work similar as in the case of DC current. So IRMS should be equal to I. So IRMS equal to VRMS upon Z. So IRMS is equal to I. So I equal to VRMS upon Z. So Z is equal to VRMS upon I. What is VRMS? 220 and I is 10 ampere. So Z will be equal to 22 ohm. Now we will find the inductance of the inductor that we have to connect to the series, so that lamp will work in similar way as in the DC current. Now XL can be calculated as, so Z is equal to root R square plus XL square. Z square is equal to R square plus XL square. XL is equal to root Z square minus R square. Now put the value of Z and R. XL will be equal to root 22 square minus 8 square. XL will be equal to root 484 minus 64, and XL equal to root 424, and value of XL is approximately equal to 20.49 ohm. Okay, now we will find the L from here. We know that using relation XL equal to 2 pi nu L, L is equal to XL upon 2 pi nu. So L is equal to, what is XL? 20.49 upon 2 pi, what is nu given in the question? 50 hertz. So L will be approximately equal to 0.065, or it is close to 0.065 Henry. Okay, so hence for working of lamp, we need an inductor of inductance 0.065 Henry. Okay, next question. In an AC circuit, the instantaneous EMF and current are given by E equal to 100 sin 30t. So V equal to Vm sin omega t, or we can write E equal to M. So voltage and EMF can be used interchangeably. Don't get confused. Okay, these are same things. So E equal to 100 sin 30t and I equal to 20 sin 30t minus pi by 4. So you have to compare it to the standard forms for LCR circuit. So expression of voltage and current is given for LCR circuit. I equal to Im sin omega t plus y and V equal to Vm sin omega t. So you have to compare to that standard forms. In one cycle of AC, the average power consumed by the circuit, you have to find the average power consumed by the circuit in one cycle and wattless current respectively. Options are 50 watt 10 ampere, 1000 upon root 2 watt 10 ampere, 50 upon root 2 watt 0, 50 watt 0. So I will give you some time to think about it. So correct option is B, 1000 upon root 2 watt or 10 ampere. So what is given in the question? So AC supply EMF is given, E equal to 100 sin 30t. AC supply current I equal to 20 sin 30t minus pi by 4 is given. So on comparing given voltage and current with standard forms, okay, what were standard forms? We have derived the expression for current, and voltage we have taken V equal to Vm sin omega t. So that were V equal to Vm sin omega t and I equal to Im sin omega t plus phi. From here Vm is equal to 100 volt, Im is equal to 20 ampere and phi is minus pi by 4. omega is 30 radian per second. So we get Vm equal to 100 volt, Im equal to 20 ampere, and phi equal to minus pi by 4. So we use the following relation for average power calculation. What is the average power? Expression for average power, P equal to IRMS VRMS cos phi. And according to NCERT equation 7.30a. Okay, so using relation Im equal to IRMS root 2 and Vm equal to VRMS root 2, expression of P becomes P equal to IRMS VRMS cos phi. Okay, so we know only the maximum values, peak values. So we will modify the formula for average power according to peak values. So I am Vm upon 2 cos phi. Okay, so P will be equal to 20 into 100 upon 2. Because Vm is 100 volt, Im is equal to 20 ampere. So cos minus pi by 4. Now, cos will swallow the negative sign. So cos minus theta will be equal to cos theta. Okay, so cos minus pi by 4 will be equal to cos pi by 4. This is property of cos. So P equal to 1000 cos pi by 4. What is cos pi by 4? Pi by 4 is 45 degrees. So cos pi by 4 is 1 by root 2. Okay, so P equal to 1000 upon root 2. And P is equal to 1000 upon root 2 watt. This is the average power. Now we will find the wattless current. So what is the wattless current? Due to which no power is dissipated across the circuit. In the case of purely inductive, capacitive or LC circuit, current is considered as wattless current because it has phase difference pi by 2 with the voltage, and average power in the case of inductive, capacitive or LC circuit is 0, due to which current in that conditions, in that combinations is called wattless current. So wattless current is represented by IRMS sin phi. Okay, so mod of phi. So we'll take I wattless will be equal to, what is IRMS we have calculated? Im upon root 2. Im is 20 ampere. So 20 upon root 2 sin pi by 4. Sin pi by 4 is also 1 by root 2. So root 2 into root 2 in the denominator becomes 2. So I wattless will be equal to 20 upon root 2. So I wattless will be 10 ampere. Okay, so hence power average consumed by the circuit is 1000 upon root 2 watt and wattless current is 10 ampere. Next question. An inductance coil has a reactance of 100 ohm. When an AC signal of frequency 1000 Hz is applied to the coil, the applied voltage leads by the current by 45 degree. Now, in the case of purely inductive circuit, phase difference between current and voltage is 90 degree. Here, phase difference is 45 degree. Means some other component is also connected. Okay, the self-inductance, we have to find the self-inductance of the coil. So, XL is given, nu is given. So you can find the L. So there is no use of phase difference here. It is only given to produce the confusion in the mind. Okay, so options are 1.1 into 10 to the power minus 2 Henry, 1.6 into 10 to the power minus 2 Henry, 5.5 into 10 to the power minus 5 Henry, 6.7 into 10 to the power minus 7 Henry. So I will give you some time to think about it. So correct option is B, 1.6 into 10 to the power minus 2 Henry. So what is given in the question? Reactance of the coil XL equal to 100 ohm and frequency of AC signal nu equal to 1000 Hz. So reactance of the inductance is given by XL equal to omega L according to NCERT equation 7.13. So XL will be equal to, what is omega? 2 pi nu. So 2 pi nu L. Nu is given in the question. So L will be equal to XL upon 2 pi nu. XL is given 100 ohm, nu is given 1000 Hz. So L will be equal to 100 upon 2 pi into 1000. Okay, so L will be equal to 100 upon 2 pi into 1000. So L will be equal to 0.05 upon pi. And L will be approximately equal to 1.6 into 10 to the power minus 2 Henry. So this is the self-inductance of the coil. Hence the self-inductance of the coil is 1.6 into 10 to the power minus 2 Henry. So the phase difference 45 degrees that is given in the question has no use in the question. Okay. So next question. An LCR circuit contains resistor of 110 ohm and supply of 220 volt at 300 radian per second angular frequency. If only capacitor is removed from the circuit, current lags behind the voltage by 45 degree. If we are removing the capacitor, current lags behind the voltage by 45 degree. If on the other hand, only inductor is removed, the current leads by 45 degree with the applied voltage. Okay, the RMS current flowing in the circuit will be. Okay, so these phase differences are given to calculate the reactances or to determine in what condition circuit is. Okay, so options are 1.5 ampere, 1 ampere, 2 ampere, 2.5 ampere. I will give you some time to think about it. So C option is correct, 2 ampere. So what is given in the question? Resistance of the resistor is given R equal to 110 ohm. Voltage of AC supply VRMS is given 220 volt. Angular frequency omega is equal to 300 radian per second is given. So using relation IM equal to root 2 IRMS and VM equal to root 2 VRMS. IRMS in the series LCR circuit is given by IRMS equal to VRMS upon Z according to NCERT question 7.25a, where Z is impedance of the circuit given by Z equal to root R square plus XC minus XL square. So now we will find what is XC and XL. To find the RMS current, VRMS is given, we have to find the Z. For Z we have to find R is given, we have to find XC and XL, or we have to find in what condition circuit is in. Okay, to find the Z. Now to find IRMS we need to find the Z of the circuit first. To find the Z we have to find XL and XC first. So in series LCR circuit, tan phi is equal to XC minus XL upon R, and according to NCERT equation 7.27. So to find XC and XL we will use this because phase difference are given. So we will find the XC and XL from here. Now when we remove the capacitor, when capacitor is removed means XC becomes equal to 0. Okay, and tan phi is equal to minus XL upon R. But we are only taking positive phase difference, means magnitude. We are not taking negative sign considering here. Okay, so tan phi will be equal to positive XL upon R. If XC becomes 0, capacitor is removed. So only R and L are there in the circuit now. So current lags by 45 degree. That means phi is 45 degree. Okay, this means, so if we are considering minus on the right hand side, means XC becomes equal to 0 and minus XL upon R. So for tan 45 degree, now 45 will also be taken as negative because in the case of RL circuit, phase difference is negative. So negative and negative from both sides will get cancelled out eventually. Okay, so we have taken positive from the beginning. So this means tan 45 degree will be equal to XL upon R. Okay, that means tan 45 degree is 1. That means XL equal to R. If we remove the capacitor, phase difference is 45 degree. That means tan 45 degrees, or we can say tan minus 45 degree is equal to minus XL upon R, or tan minus theta is minus tan theta. So minus and minus from both sides will get cancelled out. Tan 45 degrees XL upon R, and tan 45 degrees 1. So XL will be equal to R. Okay, now let's analyze the circuit when inductor is removed. Now inductor is removed, XL becomes equal to 0. So tan phi will be equal to XC upon R. And again phase difference is 45 degree with only R and C current leads by 45 degree. So this means tan 45 degree is XC upon R. This means XC is equal to R. So both XC and XL are equal to R and they are equal. When they are equal, what is the condition? Resonance. XC and XL are equal, which is equal to R. So circuit should be in resonance. Mean difference of XC and XL is 0. And circuit should be in resonance. At resonance, Z is equal to R. So XL equal to XC equal to R, circuit should be in resonance. So Z is equal to root R square plus XC minus XL whole square equal to R. And IRMS is equal to VRMS upon R. Z becomes equal to R. Because XC equal to XL. XC minus XL will become 0. So IRMS will be equal to 220 upon R. R is 110 ohm. So IRMS will be equal to 2 ampere. Hence RMS current flowing in the circuit will be 2 ampere. Got it? Next question. For a series LCR circuit, I versus omega curve is given. Okay. So 4 statements are given. To the left of omega R, the circuit is mainly capacitive. To the left of omega R, the circuit is mainly inductive. Means this is omega R. To the left of this means this portion. To left of omega R, circuit is mainly inductive. Third statement is at omega R, impedance of the circuit is equal to the resistance. And at omega R, impedance of the circuit is 0. So options are, choose appropriate options. Statement A and D only is correct. Okay, A option is A and D only. So which is the correct, which are correct statements? So option A is A and D only, B is B and D only, C is A and C only, D is B and C only. So which statements are correct? According to that, you should choose the correct option. Okay, so I will give you some time to think about it. So let's see the solution. C option is correct. Statement A and C only. So these two statements are correct. We know that you can see the graph. This is the graph for resonance. This omega R is resonant frequency at which current is maximum in the circuit. Okay. And when current is maximum means impedance is equal to resistance of the circuit. Okay. And XC is equal to XL. So this C statement is correct. At omega R, impedance of the circuit is equal to the resistance of the circuit. Now, how this first statement is correct, we will see. In series LCR circuit, peak current IM and impedance is given by IM equal to VM upon Z. When Z is minimum, IM is maximum. So Z is equal to R square plus XC minus XL according to NCERT equation 7.26. Where XC is equal to 1 by omega C, XL equal to omega L. Okay. When these two reactances are same, Z becomes minimum, IM becomes maximum. So this C option is correct. Okay, so X is equal to 1 by omega C and XL equal to XL equal to omega L. At resonance, applied frequency omega is equal to resonant frequency omega R and Z equal to R. Okay, so at resonance frequency omega is equal to the resonant frequency, which is omega R, and Z becomes equal to the resistance of the circuit, which is Z minimum, and current becomes maximum. This means at omega R, at resonant frequency, impedance of the circuit is equal to the resistance of the circuit. When frequency is lower, at resonant frequency, XC is equal to XL. Okay, now we will decrease the frequency below the resonant frequency. On the left hand, we will go left hand side of the graph. You can see when we decrease the frequency, this XC is inversely proportional to frequency, angular frequency. Okay, so if we are decreasing the omega, this XC will increase. And if we are decreasing the omega, this XL will also decrease because it is directly proportional to omega. So XC becomes more than XL on the left hand side of this graph. That means on the left hand of the graph, circuit is mainly capacitive. That's why A statement is correct also. So when the frequency is lower than resonant frequency, that is omega less than omega R, capacitive reactance XC becomes larger than inductive reactance XL. Okay, this happens because XC has frequency in the denominator, bottom. So when frequency decreases, XC increases. That means to the left of omega R, circuit is mainly capacitive. Hence option C is correct. Okay. Now next question. An inductor of inductance 2 microhenry is connected in series with a resistance, a variable capacitor and an AC source of 7 kilohertz. Okay, so AC frequency nu is given 7 kilohertz. Okay, and L is given 2 microhenry. Variable capacitor is there and an AC source is there. The value of capacitance for which maximum current. So what is the condition? Resonance. It is given that maximum current is drawn. At which frequency? 7 kilohertz. So this is resonant frequency. Maximum current is drawn. That means XC is equal to XL at this condition. And we have to calculate the capacitance, which is in the form 1 by X farad. So you have to calculate the value of X. Take pi is equal to 22.7. Okay. So I will give you some time to think about it. So what is given in the question? Inductance of the inductor is given L equal to 2 microhenry, which is 2 into 10 to the minus 6 Henry. Applied frequency nu is equal to 7 kilohertz, which is equal to 7 into 10 to the power 3 hertz. Okay, so maximum current occurs in the circuit at condition of XL equal to XC. This is the condition of resonance, which is given in the question for maximum current. So maximum current is when there is a resonance in the circuit. Okay, so at this condition, applied frequency omega should be equal to resonant frequency omega naught. And after comparing XL equal to XC, which is equal to omega naught L, which implies omega naught L equal to 1 by omega naught C. And from there, omega naught came out to be omega naught equal to 1 by root LC according to NCERT equation 7.28. Now we'll put the value of L and omega naught. Omega naught we can calculate by 2 pi nu. Nu is given. Okay. So C can be calculated. So C will be equal to, after squaring on both sides and rearranging, C will be equal to 1 upon omega naught square L. Okay. So C will be equal to omega naught is 2 pi nu. So 2 pi nu square into 2 into 10 to the power minus 6. So C will be equal to 1 upon 4 pi square. Nu is, and nu square. Nu is 7 into 10 to the power 3 square and L is 2 into 10 to the power minus 6. Okay, so C will be equal to 1 upon 4 pi square upon 4 pi square into 7 into 10 to the power 3 whole square into 2 into 10 to the power minus 6. Okay, now C will be equal to 1 upon 4 pi square 49 into 2. So C will be equal to 49 upon, so put the value of pi, pi will be equal to 22 square upon 7 square, which 7 square will go in the numerator, it will become 49. So 49 and 49 will get cancelled out. So C will become equal to 1 upon 4 into 484 into 2. So C will be equal to 1 upon 3872 farad. So after comparing it to 1 by X farad, so it will become, X will be 3872. So value of X in C equal to 1 by X farad will be 3872. Next question, an alternating voltage Vt equal to 220 sine 100 pi t volt is applied to a purely resistive load of 50 ohm. The time taken for the current to rise from half of the peak value, means current is half of the peak, half of the maximum value. It is rising from half of the peak value to peak value. So time taken for that to go from half of the peak value to peak value. So it is, options are 5 millisecond, 2.2 millisecond, 7.2 millisecond and 3.3 millisecond. So I will give you some time to think about it. So comparing Vt equal to 220 sine 100 pi t V with Vt equal to Vm sine omega t volt. So after comparing it with the standard equation, Vm will be equal to 220 volt and omega will be equal to 100 pi. Okay. So what is given in the question? Peak voltage Vm equal to 220 volt and angular frequency omega is equal to 100 pi. Okay. So resistance is given R equal to 50 ohm. Given circuit is purely resistive. It is given in the question that it is purely resistive. It is connected to purely resistive load of 50 ohm. Okay. So for purely resistive circuit, current is given by I equal to Im sin omega t. It is in phase with the voltage according to NCERT equation 7.2. So let T1 be the time when current is half of the maximum value. So we have to find the time at which current is half of the peak value and time at which current is at peak value. So then we have to subtract the time and we will find the time interval for which current reaches from half of the peak value to peak value. Okay. So at T1 time, current is half of the maximum value. That means current is Im upon 2, which is equal to Im sine 100 pi T1. Okay. So at T1, current is, instantaneous current is half of the peak value. So at what time it is half of the current value, we will find the time T1. So sine Im and Im will get cancel out. Sine 100 pi T1 equal to 1 by 2. And what is the 1 by 2 value in the terms of sine? So which angle of sine of which angle becomes 1 by 2? Sine 30 degree. Okay. So we'll compare sine pi T1 equal to sine pi by 6. Okay, pi by 6 is 30 degree. So we know that sine pi by c is 1 by 2. Then from above equation, in the place of 1 by 2, we'll put sine pi by 6. Now, both sides sine are there. So argument should be equal. So sine of 100 pi T1 equal to sine of pi by 6. That means 100 pi T1 is equal to pi by 6. Okay, so from here, pi and pi will get cancelled out and T1 will become 1 by 600 second. So current is at its half of the peak value at 1 by 600 seconds. Now let time T2 be the time when current is maximum, when current is at its peak value Im, and time is T2. Then I equal to Im sin omega t will become, so current is at peak value means Im and time is T2. So Im will be equal to Im sin omega is 100 pi T2. So now we will find the T2. So Im and Im will get cancelled out. 1 equal to sine 100 pi T1. So sine of which angle is equal to 1? Sine 90 degree. Okay, or sine pi by 2 we can say. So again we will compare. So 1 equal to sine 100 pi T2. So since sine pi by 2 equal to 1, so we'll put sine pi by 2 at the place of 1. So sine pi by 2 equal to sine 100 pi T2. So after comparing the arguments of sine, so 100 pi T2 equal to pi by 2. So pi and pi will get cancelled out. T2 will become 1 by 200 second. So current is maximum at time 1 by 200 second. Now we'll take the time from going half of the maximum value to maximum value. So T2 minus T1 equal to 1 by 200 minus 1 by 600, which is delta T equal to 400 upon 1,20,000. So delta T, time taken, will be equal to 1 by 300, which is equal to 3.3 into 10 to the power minus 3 seconds. So delta T is equal to 3.3 milliseconds. Okay, so time taken for the current to rise from half of the peak value to peak value is 3.3 milliseconds. So this is all about JEE PYQs of chapter alternating current. I hope you enjoyed the session. Thank you.